I will be teaching a lesson on how to simplify square roots. So prior to today's lesson, you had an assignment where you had to memorize your perfect squares and square roots. We did this before the laws of exponents lesson. So if you look at the left side of the screen, you will see the numbers 1 through 225 on the left column. And those are all perfect squares, meaning they are the product of the same factor repeated. As in 1 is 1 times 1, meaning 1 squared. 4 is 2 times 2. 9 is 3 times 3, etc. On down to 225, which is 15 times 15. Also important is to understand that the square root of a number means to find the factor for which, when multiplied by itself, you get that number. As in, the square root of 100 is equal to 10 because it is the factor 10 times itself. 10 times 10 equals 100. So the square root of 100 is equal to 10. Likewise, the square root of 144 is equal to 12 because it is 12 times itself. 12 times 12. So those are all important things that I will keep up while I am doing the lesson so that you can reference the list on the left. So simplifying square roots. First things first, we have to understand what this is. This symbol here is called a radical. This whole symbol. It is a radical, okay? When we look at a radical, what is also important is to look at the index. The index is the number that is in here, the crook of the radical, or the check mark of the radical. So we call this oftentimes square root because there's an understood 2. Sometimes it's not a 2. You could easily see the cube root of 5, or the fourth root of 5, or any larger root. But if you do not see the root or index, then it is understood to be a 2. Also important to understand is that the number or the expression under the radical is called the radicand. So these are all important vocab words that you would need to know for this lesson, okay? The radicand is the part under the radical. The symbol itself is called a radical. And then the index or root is the number in the check mark of the radical, which expresses how many of the same factor we would be looking for. Since this lesson is on square roots, we're looking for 2 of the same factor. Feel free to pause if I'm going too fast so that you can pause the video and put all of this information on your notes. Everything on this page should be going into your notes and will be submitted as a grade. Next, for the square root of 49, we call this again square root because it's understood to be 2. To find a square root of a number means to look for 2 of the same factor that would give us 49. Well, if you look at the list on the left, you can see the square root of 49 is equal to 7. So look that right there to the left, and you'll see square root of 49 is equal to 7. Now, why is that? Because if broken down into factors of 7 and 7, we recognize that there is a pair of factors. So therefore, it's equal to 7. So if you look over here at 125, if you notice over here on this list, I don't see the square root of 125. I see the square root of 121, which is 11, and I see the square root of 144, which is 12. I know that the square root of 125 must be in between the square root of 121 and the square root of 145. So it's probably 11 point something, but I'm not allowed to state a decimal value as its answer. So because this is the square root of a non-perfect square, so remember we talked about rational and irrational numbers, this is going to be an irrational number because 125 is not a perfect square. Irrational numbers are non-repeating, non-terminating decimals. If I were to type in the square root of 125, I would find out that in fact it was a little bit more than 11, which makes sense since 125 is in between 121 and 144 on this list. Okay? But you can't state 11.18 as an answer. That will not be acceptable. Your job is to simplify these. So to simplify means to put it in simplest form, meaning we have to break this down. So because, again, a square root means we are looking for two of the same factor, we have to think about what factors does 125 have, of which one might be a perfect square. Well, there's a few different options. If we were thinking about finding factors, I might go, well, it ends in 5, so if I divide by, 125, if I divide by 5, I get 25. Oh, look at that. 25 is a perfect square. So if I write this down with the perfect square first times the other factor, this will help me to simplify it. So that is our job, to find a factor of this number of which one is a perfect square. Why? Because this I know the square root of. So the square root of 25 is equal to 5. Now the square root of 5 is an irrational number, so the most I can do is bring that down. So I have simplified this as far as I can. Again, the square root of 125, we are looking for factors on our list over here on the left side of the screen that are perfect squares. And because 125 is divisible by 25, which is a perfect square, I can simplify that portion of the factors here and get 5 square roots of 5, and that's how I would say it. 5 square roots of 5. Okay? So if you think about it, the square root of 5 is a square root, but anything more than that, think one of them, if there are 2 of them, it's plural, so it's square roots. 3 square roots of 5, 4 square roots of 5, etc. Okay? So we would call that the square root of 5, but this as 2 square roots of 5 because it's plural. We have more than one. Okay? So 5 square roots of 5 would be our final answer. In fact, if we were to type that in our calculator, the square root of 125, enter, and then also type in 5 square root 5, enter, we would see that those are equivalent, meaning equal in value. Remember that you can also use your Calculate 84 app and type it in as well. So remember, to do a radical, you use the x squared button. So we hit second, x squared, 125, enter. And then if I want to check my answer as 5 square root 5, I'll say 5 square root 5, and it matches. So they are, see if you can see that okay. Kind of hard to see. Can I get it down there? There it goes. Now you can see that it matches, okay? So 5 square root 5 is our answer. Now, at this point, I've taught you enough that you need to go to Delta Math to do the practice. So again, 5 square root 5 is our final answer. That's how these are all going to look, all of these answers. None of the work in the problems is perfect squares. We did that when we reviewed laws of exponents. So all of these practice problems are about simplifying numbers that are square roots of non-perfect squares. Okay? So they are irrational numbers, but we cannot state them as decimals. So I'm going to keep this list up, but go to Delta Math. And if you open up your Delta Math assignment, you will see that you have an assignment called Simplifying Square Roots for 9-9. So I am going to, actually, if you'll give me a second. I will log out of this and go into my teacher account or student account so it'll look exactly like yours does. So we've got here 9-9, Simplifying Square Roots. This is what your assignment is to complete. So I'm going to go ahead and do problem 1 with you guys. So if we click on 1, your first step, it says go step by step to reduce the radical. So for the first 10 problems, they are all guided to help you recognize that you have to find the square root of a perfect square, just like I did over here, the square root of 25. But this time we're finding the square root of 180. Again, if I were to type that in my calculator, I get an irrational number because it is non-repeating and non-terminating. So that's not acceptable. I can't type that in. I have to find the factor that contains a perfect square. So if we are going to simplify the square root of 180. And there are two approaches that I'm going to teach you for simplifying radicals. And then I will end up showing you a calculator method that can work for larger numbers when we cannot easily determine a perfect square root factor. So for number one, we can look at 180 and probably recognize that this is 18 times 10. We might also recognize that it is, so I'm going to write that down, possibilities, 8 times 10, but recognize neither of those are perfect squares. We might also recognize that it is 10, that 9 is a factor of 18, so 180 must be divisible by 9. So if I recognize 180 and divide by 9, I get 9 and 20. So 9 times 20 is a possibility. Now 9 is a perfect square, so we might be able to use 9 to simplify that. However, when I look at 20, I automatically see the 20 and think about 4 and 5. So if this breaks down to 4 and 5, 4 being a perfect square, that might mean that there's a larger perfect square factor than 9. So instead of going if I'm going to take that 4, I need to recognize that it's a factor larger than 9. So if we think about multiples of 18, multiples are the numbers we get when we do like 18 times 1 is 18, 18 times 2 is, in this case, 36. Look what we recognize. 18 times 2 is 36, 36 being a square factor. So if I take my 180 and divide by 36, I get 5. If there are multiple factors of 180 that are perfect squares, we always want to try to choose the largest one. But when we look at 180, we might not immediately recognize 36. So I'm going to show you a different method first. If I were to try 18 and 10 and break this down into, say, 18 times 10, as radicals, square root of 18 times square root of 10 is the square root of 180, I might recognize that 18, again, can be broken down into 9 times 2. And that the square root of 10 can be broken down into 2 and 5, but neither of those are perfect squares. So if I do square root of 2 times the square root of 5. Well, I could stop here, but recognize that the square root of 9 is really the square root of 3 times 3. So it might look kind of crazy, but really what we have here is that 18, this 180 rather, that we started off breaking it down into 18 times 10, actually breaks down into 3 times 3 times 2 times 2 times 5, all as prime factors. Now recognize, if I type all that in my calculator, 3 times 3 times 2 times 2 times 5, I get 180. Well, again, the whole point of a square root is to find pairs of factors. So at this point, I have found a pair of 3's which can come out, really because this is 9 and the square root of 9 is 3. And I have a pair of 2's for which 1, 2 can come out, recognizing that 2 times 2 is really 4, and the square root of 4 is 2. But the 5 does not get paired up. And remember, because my index is 2, I'm looking for pairs of factors, so this has to stay. At this point, I'm ready to simplify this answer, and whatever I can pair up gets multiplied together and left on the outside, so that's 6, with the square root of 5 remaining here under the radical. So this is kind of a longer way of simplifying the square root of 180. You do not have to do this every time. But recognize that now if I were to check my answer, the square root of 180, and then type in 6 square roots of 5, they match. They are equivalent. And I know that I'm finished because 5 is an irrational number for which, the square root of 5 is the square root of a non-perfect square being irrational, and there are no perfect square factors. So I've simplified 5 all I can. So again, why did I start with 18 and 10? Well, I could have started with 9 and 20, but then that 20 would need to be broken down into 4 and 5. And that 4 broken down to 2 and 2. So the shortcut really is try to find the factor that is the largest perfect square factor. If we do that and recognize that the square root of 180 is really the square root of 36 times the square root of 5, then we can get to the square root of 6 being 6. We can get to our answer a whole lot quicker, okay? So 6 square roots of 5 is our answer for number 1. So make sure when you take notes, I see all this work. Not all of them are going to be this much work, like I said. If we go before skipping down to number 6, let me go over here. I apologize. So let's go over here. We broke this down into the perfect square factor that was the square root of 36 times the square root of 5. So we click try and then break this down. The square root of 36 will go here on the outside, and what cannot be broken down any further into factors that are perfect squares is right here. So 6 square roots of 5. And then we submit our answer, and it tells us yes. So this is the fastest path, okay? This is a fast path. If you look here in your examples for your answers, it's going to also show you a slower path. So another option instead of 18 times 10 might have been 4 times 45, where the 45 then breaks down into 9 and 5. But then the square root of 9 is 3. So you can see it's a very similar path to what I did, just starting with a different set of factors. Notice the length of work here is much longer than here when we are able to find a perfect square factor. Okay? So next we're going to go ahead to number 6. So I'm going to go back here and click on 6. And we see that we have the square root of 200. So over here on paper, I have, for number 6, the square root of 200. When I look at 200 and then consider the list of perfect square factors over here on my left, I want to try to find factors of 200 for which one is a perfect square. So we could think of this as 20 and 10, but neither of those are perfect squares, okay? 20 and 10 are not on this perfect square list. If I think about 4 and 50, 4 is a perfect square, but 50 is not. But even better than that, I could maybe do 2 times 100. So if I break this down into 2 and 100, 2 cannot be broken down any further into factors for which one is a perfect square, and then we have the square root of 100. So if I were you, I would do the square root of 2 times the square root of 100 because it's the largest perfect square factor. Yes, we could try 4 and 50, but then it's going to have to be broken down further, so I would avoid that. So if you can do that, then the square root of 100 is 10, so it's going to go here on the outside, where 2 remains our radicand because it cannot be simplified any further. So 10 square roots of 2. So again, think of the set of factors for which the factor is the largest perfect square factor. Okay? So again, a slow path might be, if you were to try 4 and 50, you could take the square root of 4, but then 50 would need to be broke down into 25 and 2. Then the square root of 25 would be 5. And then you would multiply any of these integers out here together to get 10. Okay, so again, there's more than one path to get to your right answer. The fastest always being to find the largest perfect square factor. Okay, so over here in your notes, again, we broke it down into the square root of 2 times the square root of 100. Then put the 10 in the front for the square root of 100 is 10. Of course, when you write it, there's no rhyme or reason about which one you put first. You could certainly write a square root of 100 first and the square root of 2 here. But again, every time you do this, if you type it in your calculator first, you'll know if it matches. So square root of 200, 10 square root 2. So just like last week when I taught you to verify your answers, please verify your answers so you don't get frustrated trying it in Delta Math and it not working out. Okay? So now I'm going to try to move on quickly to number 9, but I want you to start thinking in your head about factors of 32 rather, for number 9. So square root of 32, when I think of the square root of 32, I think, oh, it's an even number. So if I'm trying to find factors, I can always take my 32 and divide by that even number of 2. Well, look what you notice. We get 2 and 16. So I can multiply 2 and 16. Are there other factors of 32? Sure. 32 divided by 4 is 8. So that's 4 and 8. And maybe even larger than 8 would have been 16. So I probably would limit it here. So can I try 4 and 8? Let's try it out. So if I do square root of 4 times the square root of 8 and try it, I can simplify the square root of 4 to get 2 and keep my 8 here. So let's see what it does. And then I have to take my square root of 8 and break it down into, I can use 4 and 2. So notice here, this time I'm not starting with the largest perfect square factor, but it's still letting me explore by doing different roots. Okay? And now that I've done that, I can take this square root of 4 and put the 2 here because the square root of 4 is 2. Bringing down this square root of 2 here. And if it keeps accepting it, that means I'm making correct progress. So 2 times 2 is 4. So I'm multiplying this 2 and 2 out here to give me 4, and I'm keeping 2. So if I think my answer is 4 square roots of 2, I'm first going to verify it, right? So again, square root of 32. And then let's see if 4 square root of 2 comes out to match. And it is equivalent, so I'm good to go. So remember that you and your friend might not try the exact same numbers. Me as a teacher and you as a student might try different numbers. We still got to the same answer, 4 square root of 2, as if we had used 16 and 2. So I am going to try to push you to get in the habit of trying to find the set of factors for which you find the largest perfect square. So this would have been ideal over this because it's less steps. But the square root of 16 is 4. And that would match. Okay. Next, for square root of 50, so I'm going to go back it up here, and these are just problems that I pre-selected. I'm going to type in the square root of 50. So the square root of 50, we should think that, well, I could maybe use 5 and 10. And if I use 5 and 10, do any of those break down into a perfect square factor? Well, at this point on 11, hopefully you've done enough of these that you're going in and practicing, like finding these perfect square factors. Well, 5 and 10, neither of those are perfect squares. I could break down the 10 into 5 and 2, but maybe it would be better to use, say, 25 and 2. We should definitely know our multiples of 25 because 25 is going to be a common factor. In fact, if a number ends in 0, or 180 ended up in 0, but it's not divisible by 25. But if it's a multiple of 100 or a multiple, then it's a multiple of 25, okay? So if you think about multiples of 25, we've got 25, 50, 75, 100, 125. Think about money, right? 150, 175, etc. Any of these numbers here are going to be divisible by 25. And that is a large perfect square factor. So if I break this down into the square root of 25 times the square root of 2, then the square root of 25 gives me 5 square roots of 2. So I'm hoping that as you work through this work, you will start to be able to do things quicker and quicker in your head. So I'm going to type in 5 and come down here. I've got this set up so that all you have to do is click that instead of using your keyboard. Let's see if 5 square root 2 is our answer. Now again, I definitely want to use my calculator to check. Yep, square root 50, square root 50 and 5 root 2. And those are equivalent. Sorry about that. So you should be able to feel confident about that. So I'm going to submit my answer. And I'm good. So again, they're walking you through here. What perfect square divides into 50? And it ends up being 25. So it makes it really easy to use the square root of 25 times 2. Square root of 25 down here, bringing you 5 square root of 2. So feel free to continue to use the tools that are built into Delta Math, like your video and your examples. So I'm going to move on to 15 and see if we can't do this one maybe in our head. So again, if my job is to think, what factors of the square root of 12 can I break down, one of which being a perfect square? 12 is not a big number. So if I look over here on my list on the left side of my screen, which of these perfect squares are factors of 12? Well, the only one on the list is 4. So I would want to use 4 because the square root of 4 is 2. So I'm going to come over here and quickly do square root of 4 times the square root of 3, breaking down the square root of 4 into 2, and bringing down the square root of 3. So our answer should be 2 square roots of 3. If we verify that in our calculator, 2 square root of 3. Let's see if it works. And it does. So continue to think about the ones that you might be able to identify that are perfect squares. And the last thing I want to do is show you how on a problem like 20, where you're going to look at it and go, I don't know any perfect squares. Like 50, I can think of that and go, oh, it's divisible by 25. 12, I can look at that and go, oh, it's divisible by 4. But what if it ends in, like, if you've got 192? I don't know any common factors of 192. I know it's even, so I could try 2. But I'm going to show you a cool calculator trick. So over here to the left, or to the right, I want you to put calculator method. So the calculator method, you're going to take your Radicand and in Y1, type in your Radicand divided by x squared, because we're trying to find a perfect square factor. So that means for here, for this one, I'm going to type in 192 divided by x squared. So whether you use your graphing calculator, if you have one, or your calculator app, that's what I'm going to use with you guys. Try to make sure you can see it real well. Hold on. Try to focus it here. I'm going to go to y equals. Oh, it's not showing up very good. If I get closer, yeah. I'm sorry, it's going to get blurry. So again, I'm going to type in 192 divided by our x, so this x to the right of the green button. So divided by x, and then I'm going to hit this squared button here that says x squared. So it should look like that, 192 divided by x squared. So now what I want to do is look at my table, because anything in y equals has a table. So to get to table, I need it. Table's right here above the word graph, so I'm going to hit second graph. My job is to look for an ordered pair on my list that is the very last integer ordered pair. So remember, integers are positive and negative whole numbers. So I'm going to move my finger to scroll, or if you have an Android phone and you're using your Wabbit Emu TI-84 calculator, which is just like this, you'll just hit the down arrow to scroll down. But I'm going to look for the last integer ordered pair. So I see the integers 1 and 192, 2 and 48, 4 and 12, and then 8 and 3. And once I get to where the decimal values are below 1, there's no more looking, because from then on, everything's a decimal. So I'm going to choose 8 and 3, and this is going to be my answer, 8 square roots of 3. So in your notes, I should see a table where you say 8, 3. And what this means is we translate this into an answer that is 8 square roots of 3. So your answer should always be whatever this x value is, root whatever this y value is. So this is your x and y table. So this last integer ordered pair, so I'm going to put up here, look for the last integer ordered pair to write your answer. And it really is that easy. 8 square root of 3. 8 square root of 3. So if I'm sorry, I'm going to focus this again. So in other words, if I type in the square root of 192, that's not right. Square root of 192 and then type in 8 root 3, it's going to be equivalent, okay? So I'm just going to come over here in Delta Math and type in 8 root 3. And it's really that simple, guys. So could we have found it by hand? Sure. If we do some dividing by these larger perfect squares, if we divide by 64, we get a 3. Well, guess what the square root of 64 is, guys? 8. 8 root 3. We just found it a different way. So keep remembering to do that, okay? We're going to do one more. I'm going to skip to 23. I know it's kind of been a long lesson, but it's trying to get you to progress from step by step to understanding that for harder ones, it's okay and acceptable, of course, to use your calculator. So I'm going to go to 23. And we're going to do the square root of 845. Now, when I look at 845, I immediately think, well, it's divisible by 5, so maybe it's 25. But you know what? That's just too big. So we're just going to go in here in our y equals, clear, well, I'm going to keep what I have and just, if I want, I can delete out the 192. And I'm going to type in now 845. So if you want to start all over and just hit 845 divided by x squared, that is perfectly fine. So if I'm finding again the square root of 845, I can now look at my table, so second graph. And my job is to look for the last positive integer order pair. I do not need to be looking here in the negatives. It's not helpful. So, 1 and 845 is an integer. Ooh, there I go again. 13 and 5. So I'm looking for these positive integers here. Once I get here, everything after that is just decimals. So that's my last integer order pair was right here, 13 and 5. So that is my answer, remembering that my 13, my x value goes on the outside, and my y value goes under the radical. So if I see 13.5, in my table, I'm going to translate that into 13 square roots of 5. So here, let's type it in, 13 square root of 5, submit. Woohoo! All right, no work for these because I custom made some of these problems, all right? So your job is just to go back, make sure you type in all of these answers. So I've done 1, 2, 3, 4, 5, 6, 7 of them. So you just need to go in and finish the remainder of the assignment here, and this will be due tomorrow at midnight. Good luck.